Assalamualaikum warahmatullahi wabarakatuh. Okay, now we move on to our final chapter, which is synthesis of coordination complex. Okay, so this is similar lah on what you have learned during your organic class, but with the organic class you learn on how to synthesize organic compounds, and for this course you will learn how to synthesize metal complexes. Means how you for example you combine metal with ligand and then to get the metal complex. So there are three ways to synthesize metal complex. First is by substitution reaction, second redox reaction, and finally ligand coordination reaction. So for this topic we will only focus on substitution reaction and ligand coordination reaction. Redox reaction actually you have learned, it's not totally you learn regarding the metal complexes, but you have learned the redox reactions during your physical class. Kan you tengok the redox properties. The first method is substitution reaction. So this substitution reaction is divided into two. So whether you substitute the metal or substitute the ligand. So it means that with the metal substitution reactions, so for example you have metal ligand M1 with ligand A, for example, and then you need to substitute this M1 into other metals, so you substitute the metal. So it becomes M2La, while for the ligand you will substitute the ligand. So instead so you will have similar metal. Maksudnya the M1 La, then you react with Lb, you substitute B, you substitute the ligand, and then you will get M1 Lb. So it means that your product, your metal product and your metal reactant are the same. Yang atas ni untuk substitute metal, so your ligands will be the same. So you substitute the metal. Maksudnya you gantikanlah, substitute. So for metal substitution, the occurrence of the metal substitution reaction will be more difficult. Maksudnya susah. Agak susah lah if you compare with the ligand substitution. Susah you nak substitute the metal ni. Susah you nak gantikan the metal. Why? Because metals usually have ligand. They akan surround with ligand. So susah lah you nak take out this metal and then gantikan with another metal. Dia nak substitute, so this will leave the group and this will come along lah, ataupun will fill in the blank here. So agak susah untuk metal substitution with the ligand substitution because you have ligand surround your metal. So for for substitution reaction, so you have three factors for substitution reaction. So one is the inert and labile. Second one is the solvent factors ataupun solvent selection. How you select your solvent. And then finally you have the trans effect factor. So these factors, okay, will have contribution lah, okay, towards this substitution reaction. So kita tengok satu-satu. Okay, what is inert and labile factor? Okay. For inert factor, okay, so when you have a reactions, okay, with inert punya factor, so you will have a slow reaction. While labile, you have fast reaction. So when we say it has slow reaction, so it means that your reactions will take longer time. Okay, with labile, sebab dia fast reaction, reaction yang cepat, so you will have a shorter time to complete your reaction lah. Okay, and then untuk inert, okay, so inert factor, because you have slow reaction sangat slow, so you need some push factor, okay, untuk nak make it happen lah. Okay, so you will require some push factors such as energy, okay, ataupun heat, okay, ataupun light, okay, ataupun you could use some catalyst, okay, ataupun electrical, okay, so adalah anything yang will do, okay, the push factor towards your reaction, maksudnya yang membantu reaction you. Okay, with labile, okay, because it is a very fast reaction, sometimes you can get a product in a shorter time, ataupun boleh kata sekelip mata lah macam tu kan. So you don't need any push factor, okay, so you can just prepare your samples, okay, by just stir it, maksudnya stir saja pun you dah boleh dapat kompleks. Okay, tak perlu panaskan, tak perlu put some catalyst in it and etc. Okay, so with that, okay, so with inert punya factor, so you will get, okay, your product tu, okay, so you will get a low spin complex. Okay, so bila sini low spin, of course ini mestilah vice versa lah. So with labile, you will get high spin complex. So when you say low spin complex, it means that if you characterize your material ataupun your complex, bila you characterize, maknanya you tengok dia punya magnetic properties, so you will have low magnetic properties. Okay, kalau high spin pula, kan, you dapat high spin complex, and then when you test experimentally, kan, kalau you test with the magnetic moment value, okay, and then you will get a high magnetic properties-nya value. Okay, so from there, okay, so from here, okay, you can know lah, ataupun you can have a diamagnetic compound ataupun complex. Okay, so with higher magnetic properties, okay, you tend to get paramagnetic complex. Okay, so with that kita dah tahu dia akan form low spin complex, so you boleh agak lah, okay, what is the ligand preference untuk inert factor. Okay, so mestilah dia punya ligand must be strong field ligand, which is the CN, CO, okay, PPH3 and etc. Okay, while this one, because it forms a high spin complex, so it means the ligand, okay, prefer, okay, as weak field ligand, okay, such as your fluoride, bromide, and etc. lah. Okay. Why? Okay, it states that with inert factor, you will have a slow reaction, while with labile factor, you have a fast reaction. So why is this occur lah? Okay, so with inert, okay, so remember you have ligand, your preferences of ligand will be a strong field ligand, okay, with CN, CO, and etc. lah. And then when you arrange your electrons, okay, based on the d orbitals, okay, because if it has strong field ligand, so then you will have a low spin complex. So your D splitting, okay, so your 1, 2, 3, 4, 5, 1, katakan you ada 5 electrons, okay, so your splitting, this is an octahedral, so it will be T2G at the bottom, EG at the top, and then this is a low spin species, so you will arrange your electrons at the lower level, okay. And then with labile factor, it is a fast reaction. You have weak field ligand, such as your Cl minus, bromide, and etc. So this, okay, will form ataupun will have the arrangement of high spin complex. So sama juga when you have your D orbital, ni D5 kan, so kita buat juga D5. Okay, when you do the splitting, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and you have the splitting 1, 2, 3, 1, 2, T2G and EG, and then this is a high spin, so you arrange like this. Okay, so as you can see here, okay, the T2G, okay, the energy level for the T2G for the low spin, okay, so the electrons is sort of occupied, okay, sebab ni 5 lah, tapi kalau dia bukan 5, kalau dia 4 pun, okay, so dia punya T2G will have higher electrons, okay, kalau 6 lagi lah dia dah fulfill. Okay, while for the high spin complex, okay, as you can see here, your T2G has lower in electrons. Okay, so when you have higher in electrons at T2G level, so this, okay, will prevent, okay, prevent the attacking group tu kan, sebab you dah ada attacking group. Attacking group dia maksudnya group compound yang nak substitute tu. Okay, so with sort of higher electrons at T2G, you will prevent the attacking group to approach your complex. So macam you halang lah dia kan, sebab dia macam penuh lah dekat T2G. That's why you get a slow reaction. Maksudnya you need a push factor untuk nak remove the current ligands, and then you nak masukkan ataupun you nak insert lah the attacking group ni to your metal complex. Okay, while with high spin complex, you have lower in electrons. Okay, your number of electrons lower in T2G. Okay, so yeah, you sikit. So it means that you the attacking group tu, okay, have the ability ataupun you macam allow lah the attacking group to approach your metal. Okay. Okay. So ibaratnya with high spin, okay. So you ada rumah, you ada banyak bilik, tapi bilik you ni seorang je yang duduk. Okay, so kalau ada tetamu yang datang, so you might invite your guests, okay, and then you boleh sediakanlah, okay, the tempat tinggal for your guests. For let's say this one, okay, for the low spin, you ada rumah yang sama besar macam rumah lebar ni, okay, but okay, currently, okay, bilik-bilik ni dah dipenuhi, kan, dah ada orang, katakan 3 orang setiap bilik, okay, and then ada tetamu datang, and how you gonna squeeze tetamu yang ada ni masuk dalam rumah you. So it is impossible lah, ataupun dia tak selesa lah, okay. So that's why so you kena berfikir panjang macam mana you nak letak orang tetamu. While this one, tetamu datangnya you macam boleh dah jemput, okay, masuk, and then you boleh fill up the room yang tak berapa penuh tu. So same analogy ni can be applied to this factor lah. Okay. For example, okay, so this is the inert punya factor. So you have metal and you have your ligands, okay, and then you need to substitute, okay, one of the ligand. Ni ligand baru yang you nak substitute with one of the ligands ataupun one of the ligand yang sedia ada lah. Okay, so remember, if it is an inert factor, so you will have a low spin complex ataupun you will have a strong field ligand. Okay, so you ada strong field ligand. So your ligand ni, okay, will have occupancies of electrons banyak dekat E2G. Okay, so the ligand ni will be inserted, okay, in between of the axis. So dia akan attack your metal ni in between of your axis, of your ligand axis. Dia akan attack kat sini. So dekat DXY, DXZ, DYZ, dia akan attack kat situ sebab dekat X axis, Y axis and Z axis ataupun X square, Y square and Z square is already occupied with the ligand. Okay, so dia akan masuk dekat antara dua bond ni, So dia akan try untuk masuk kat situ. Okay, so bila dia try nak masuk, okay, so of course you will have some repulsion. Mestilah ada repulsion, kan? You ada ligand kat sini, dan you nak tolak masuk lagi, so you might have some repulsions. And again, remember, if it is inert factor, so your T2G ni elektron dia banyak. So bila dia elektron dia banyak, so the repulsion will be higher lah. So dia akan high repulsions. Okay, so in that case, sebab itulah, for example, you nak leave this ligand. This ligand will be the leaving group, and this ligand yang baru ni will be the attacking group. Maksudnya you nak keluarkan this ligand. So that's why, in order untuk you nak break this bond ataupun nak keluarkan bond ni will be slower. Okay, sebab dia nak masuk pun susah, payah, because of the repulsions, because of too many electrons at T2G. Okay, so untuk dia nak lepaskan this ligand will be slower. So maksudnya the reactions will occur slower. Okay, so this will be vice versa with the labile. So terbaliklah. So kalau labile, the ligand tu senang. Okay, so this is your ligand. So this is your metal. This is your current ligand. Okay, and this is your new ligand. Okay, so this is your new ligand. So your new ligand, okay, senang nak attack the metal. Why? Because the electrons at T2G is lower. So you will create lower repulsion. So bila ada lower repulsion, okay, so senanglah dia nak masuk. Okay, senanglah dia nak attack ke metal. So bila dia senang nak attack ke metal, so senanglah this ligand leave. Okay, itulah yang maksud dia slower and faster. Then we look at the second factor, which is solvent selection. Okay, so usually, okay, in the lab, kalau biasa-biasa, and then during your inorganic lab hari tu pun you have experience, okay, preparing metal complexes, okay. So, and then dalam lab-lab yang lain pun, kalau you buat reactions, so usually those reactions will carry out in liquid phase, kan? Maksudnya your reaction ni you akan buat reaction you dalam liquid phase. What it means by this is when you have A, kan? A, and then you need to dissolve A first, jadi solution A, and then you will react with B, ataupun okay, you dissolve B in a solution, then you get solution B, and then you react solution A to solution B. So it means that when you do, okay, reactions, ataupun when you do the synthesis, so you will carry out your reactions too in liquid phase. So therefore, you have to choose your solvent wisely. Okay, so the choosing of solvent ni penting lah, is very important. Kenapa I say important? Because the solvent selection ataupun solvent preferences ni, ataupun when you choose your solvent, okay, you will determine whether your reactions will have a fast reaction ataupun you will have a slow reaction. So it will have the impact of fast reaction and slow reaction. So with fast reaction, okay, your solvent yang you guna tu, your solvent will have high solvating effect ataupun high solvations towards your leaving group. Maksudnya dia lebih suka dissolve the leaving group. While with slow reactions, your solvent, okay, will have lower solvating effect on the attacking group. Okay, maksudnya bila you have a fast reactions, your solvent will have more solubility on your leaving group. So leaving group ini senang nak soluble dalam you punya solvent, that's why dia senang nak keluar. Bila senang nak keluar, then you will have fast reaction. While for the slower reaction, okay, your solvent, okay, have lower, okay, solvating effect on the attacking group. Maksudnya dia ada lower insolubility lah. Okay. Apart from it, okay, apart from it, your for the fast reaction, your solvent have high boiling point. Okay, while slow reactions, you have a lower boiling point. So bila you ada high in boiling point, so you will have higher thermal energy. Why I say higher thermal energy? Sebab you require more heat, okay, in order for your solvent to evaporate. Okay, so with more thermal ataupun more heat, maksudnya bila you did your experiments in a higher temperature pun your solvent ni remain, maksudnya tak adalah dia hilang, dia evaporate and etc. So your reactions ni okay will have with the higher energy ataupun higher heating ni, so your reactions ni will have the ability ataupun will have the push factor to break your M leaving group. Okay, while with the slow reaction, okay, so you will have the vice versa lah, lower in boiling point, maksudnya you tak boleh guna higher energy, higher thermal. So maksudnya you just boleh buat you punya reaction under lower thermal energy. Okay, so when you have lower thermal energy, so kalau katakan this is your metal and your leaving ligand ni, so susahlah dia nak break. Sebab apa? Sebab you ada push factor you ni lemah. Kalau push factor you tinggi, so lagi senang dia nak leave the group. Okay, and apart from this, okay, the solvent selection ni juga, okay, so you perlu tengok juga about regarding the quality and the quantity of your solvent. So these two factor also affect, okay, the replacement of your leaving group. Okay, maksudnya kalau you ada solvent A, okay, yang you tahu solvent A ni boleh bantu untuk nak percepatkan the leaving group of your ligand ataupun the ligand ni leave your complex. So you ada, katakan A ni ada quantity yang tinggi, and then satu lagi you ada solvent with lower quantity, and of course with the higher quantity ataupun higher volume ni, okay, so you will have faster reactions. Sama juga dengan quality. Quality means kalau yang B is concentrated solvent while A is a diluted solvent, so of course B will have more will have faster reaction rather than this one. The final factor is the trans effect factor. Okay, so as you can see here, okay, statement ni lah. Okay, so in summary, okay, so the trans ligand, okay, when you have a trans ligand, okay, ataupun trans complex, kan, for example this is your complex A, B, kan, for example you have a trans complex, so your trans ligand will leave first, maksudnya dia ni akan it will be chosen lah, okay, to be the leaving group, so dia akan yang terkeluar. Okay, and then, okay, when you make ataupun when you try to design a complex with trans symmetry, okay, maksudnya trans geometry dia tu trans, okay, so you will have to refer to the trans ligand punya series. So dia ada satu series, okay, on the next slide. So dia ada one series macam you punya series on spectrochemical series tu, the weak field and the strong field ligand. So the trans ni pun ada satu series. Okay, so katakan sini A and then sini blah 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 and then B. So it means that A will have a higher trans effect. Okay, so maksudnya kalau you react A with your metal complex, so this A, okay, will form a trans complex. Okay, rather than B. Kalau you react B with your complex, so your B, okay, will prefer to form in a cis complex. Okay, so nampak beza. Kalau A ni the trans effect dah higher, so bila you buat reactions, so your product, okay, will have a trans complex. Okay, so this effect is actually important lah. Why important? So it will be important when you have a square planar and octahedral complex. Bukan bermaksud kalau tetrahedral tu tak penting, tapi tetrahedral usually kita tak nampak sangat its cis or trans effect. Apatah lagi if it is a linear complex. Sebab square planar, so you will have M A B A B ni cis. Okay, so A B B. Okay, so you can have the trans effect for square planar. Same goes to your octahedral. Tengok balik your notes during your inorganic class. Okay, so usually with cis and trans ataupun fact ataupun mer. Okay, so yang ini kita boleh tengok fact and mer. So both can have cis and trans. So sebab itulah penting, okay, untuk kita the cis ataupun trans effect ni for these two complexes, these two geometry ni. So this is an example. If you want to design a complex, okay, with cis or trans geometry. Okay, so for example here, okay, you for complex A, okay, you nak prepare a cis diamine dichloroplatinum 2. Okay, and while the other complex, okay, which is B ni, okay, you want to prepare trans diamine dichloroplatinum 2. Basically, both of these complex A and B ni, both complex ni have the same molecular weight, has the same elements, okay, semua elemennya sama, platinum 1, 2 NH3, 2 Cl. Okay, cuma the difference is the kedudukan the ligands. Okay, with A you have cis geometry and B you have trans geometry. So macam mana you nak prepare if cis geometry for example? Maknanya you tahu you nak kena prepare cis, bukan you nak prepare trans. So how do you prepare the cis geometry? So you have to look at the trans strength ataupun trans effect strength series, kan? You pergi tengok nanti the next slide tu ada the strength of trans ligand. Okay, so dia ada strength dia. So NH3, okay, NH3 is lower than Cl. Okay, regarding trans effect. Maksudnya NH2 pula NH3. Maksudnya if you react your complex with NH3, your complex, okay, will form a cis complex. Okay. While if you react your complex with Cl chloride, so your complex, okay, will form a trans geometry. Okay, sebab itulah penting juga untuk you nak tahu regarding the trans effect. Sebab ada certain applications, okay, that application cannot macam tak boleh berlaku lah, ataupun dia tak boleh menggunakan cis geometry, for example. Dia akan berjaya if it has a trans geometry. Maksudnya kalau katakan you nak buat application dia, for example lah, ni example sahaja. So for example you nak buat nak buat apa? For example you nak buat solar cell lah, for example. Okay, you nak buat solar cell. Okay, so in order for this applications ni, okay, to be successful, you need to prepare a trans complex. Let's say you prepare a cis complex, so you cannot have that applications. Maksudnya you tak boleh pun guna the cis complex to these applications. Sebab itulah penting untuk you nak tahu the trans effect. Okay, sebab you tak boleh nak control of course you can control lah kalau you buat kalau you gantikan the ligands, ataupun kalau you directkan the ligands. Of course you can have your preferences, but if you have something like this, okay, and then you just react another ligands, so you perlu tahulah with these ligands whether you have a cis complex ataupun you will have a trans complex. Now we look at the final synthetic method, which is ligand coordination reaction. Okay, so with this method, so macam mana dia berlaku is actually dia berlaku with the effect of hydrolysis. Okay, so what is hydrolysis? Okay, supposedly you know lah. Okay, so kita just refresh a little bit. So hydrolysis is the breaking, okay, ataupun the breakdown of your material. Okay, due to what? Due to the reactions of ataupun the reactions with water. Okay, so bila jadi reactions with water, okay, so you can your initial structure tu will torn apart lah. Okay, and what happens, and it will replace with the water. Okay, so why must, okay, soalan dia, okay, so why must ataupun why the metal ion ni must be dissolved in water ataupun dalam polar solvent. So why? Okay, so these ions, okay, so this metal ion, okay, so this metal ion lah ataupun M plus will have the ability, okay, not the metal ion, the H2O, okay. So the H2O is actually have the ability to solvate ataupun to dissolve metal ions. Okay, and then when this happen, so you will have metal with water as its ligand, ataupun metal ni will coordinate with water ataupun aqua as the ligand. Okay, so macam mana dia boleh berlaku, and it looks spontaneous. Okay, nampak tak dia macam spontaneous saja, bukan, daripada metal ion react with water, and then eventually you will form an aqua complex. So why? Okay, kenapa? Sebab you look at the solvation here lah, the water lah, in this case the water. So water is actually a weak field ligand. Okay, and then when you have a weak field ligand, so eventually you will have, okay, a high spin complex. Betul tak? So it means then your complex ni, your aqua complex ni is a high spin complex. So with high spin complex, kalau you refer back to your previous slide with high spin complex, so you will have a labile substitution. Okay, with the labile substitutions, okay, you will have a fast reaction. Sebab itulah this aqua complex will occur spontaneously. Now we already know regarding the metal aqua complex, which is metals ions you react with aqua ataupun you solvate ataupun you dissolve your metals with water, then you will get metal aqua complex. Okay, so this complex ni, metal aqua complex, when you further react, okay, kan you ada MH2O, okay, in an octahedral geometry lah, sebab dia ada 6 coordination number. So H2O, H2O, H2O. So when you react this with a strong field ligand, tak kisahlah apa-apa, CN ke CO kan, if you react with a strong field ligand, you the conversions of the ligands ni, okay, maksudnya dia tukarkan, okay, dia substitutekan ligand ni with the strong field ligand, okay, spontaneously. Okay, so dia akan berlaku spontaneously. It is the same phenomena observed with medium field ligand. So sama juga, dia akan berlaku spontaneously. Medium ni katakan NH3. But what if you react your aqua complex with weak field ligand? Okay, so bila you react with a weak field ligand, for example Cl minus kan chloride bromide, so kalau you react with chloride, so your final product tu, okay, ataupun your reactions, okay, kita tengok pasal reaction dulu. So your reactions may have a slower reaction, okay, and then based on this structure ni ataupun this complex ni, so supposedly it has 6 H2O kan, with Cn for example kan, you can have 6 Cn occupy ataupun exchange with the 6 water, but with weak field ligand it will partially exchange tu, maksudnya maybe tak semua water will be replaced with Cl. Okay, and the direction will occur very slow. Okay, so bila kita cakap pasal Cl ataupun chloride ions, so these chloride ions, okay, the sources of the chloride ion can be from salt. Okay, salt ni such as sodium chloride, still chloride ion, ataupun salt ni from acid. Okay, for example HCl kan, so Cl ni pun chloride ions. So kalau the ligand sources ni from salt, maksudnya you react your aqua complex with salt, okay, weak field salt, so your product ni, okay, susah nak dapat lah, ataupun you won't get the metal chloride complex. Okay, you tak dapat. But with acid, okay, kalau you ada acid, so you may get ataupun you may replace the water ligands ni with chloride. Okay, but of course not all the water ligand ni boleh remove lah. Okay, memanglah dia boleh, cuma you need to have extra apa ni, push factor and etc. lah. Okay, and the amount of chloride ni juga will depends on the concentrations of your acid. Okay,